Hello dear students, in this video we will talk about parallel connection. Parallel connection is the connection where different loads are connected or the resistors are connected parallelly. You can see this is a circuit. Now this is a series of cell, that is a battery. Now this is an emitter connected with the circuit in series. The job of the emitter is to measure the value of the current I. Now this is voltmeter. Voltmeter is connected parallelly. Now what voltmeter does? Voltmeter measures the potential difference between two terminals. Now here in this circuit I current is flowing. Now there are three resistors R1, R2 and R3 are connected in this circuit parallelly. So in the last class I explained you what is series connection. Series connection is the connection where the loads are connected in one particular single line. Suppose this, like this. Here one's end here, second begins from here, then this is third. So this is first one, this is second one, this is third one. So this type of connection is known as series connection. In parallel connection, what happens? What is parallel? Parallel means if you consider these type of lines are known as parallel connection or parallel lines. So here what we are doing, we are taking three resistor. This is first resistor, this is second resistor, this is third resistor. And these resistors are like the parallel lines where they are connected with one particular point. That end terminals of these resistors are connected like this. Okay, these three are parallel. Now these are connected with cell or battery. Okay, so here you can see these three resistors are connected parallelly with each other. So here with the help of this emitter we can find out the value of current. With the help of voltmeter we can find out the voltage or the potential difference. Okay, so and we can calculate the things that we need here. Okay, so here in this circuit, suppose I current is flowing, I is the current. So the total current I is equal to the sum of separate currents through each branch of the combination. So here what happens? Here I current is flowing through this wire. Okay. Now here you can see I current is flowing. When this I current comes here, there are three branches. Okay, this I current will divide into three branches. Here we do not consider this one because this is voltmeter. The job of the voltmeter is to measure potential difference. Here we will not consider this one in terms of current. So there are three resistor. Through three resistor, the I current will divide. Suppose in the first line, I1 current is flowing. Here in the second line, that is in this resistor R2, I2 current is flowing. Here with the R3, I3 current is flowing. So through the first resistor R1, I1 current is flowing. To the second resistor R2, I2 current is flowing. To the third resistor R3, I3 current is flowing. So when these three current pass through the resistor individually and come to this point Y, at this point Y what will happen? Again these three current will be added, that is I1 plus I2 plus I3. So from here I1 current is coming, from here I2 current is coming, from here I3 current is coming. So these three current will be added here and pass through this wire. So what is this value of I1 and I2 and I3? It will be equal to I. So this I current is again coming back. Now this I current will pass through the emitter and it will come and end here with the battery. Okay, so this is parallel connection. In series connection, we were measuring voltage that is V equal to V1 plus V2 plus V3 plus V4 respectively as per the number of resistor. But in case of parallel connection, I equal to I1 plus I2 plus I3 like that. Okay. Now here I equal to I1 plus I2 plus I3. Okay. So if we add another resistor here, so it will be again I4. So let Rp be the equivalent resistance of the parallel combination of the resistor. So here, suppose these three resistors can be replaced by one single resistor, okay, as we did in the series connection. So there are three resistors connected here parallelly. Suppose these three resistors can be replaced by one single resistor. So that is equivalent resistance or equivalent. It can be said as R equivalent or RP. R P. P for parallel connection, R for resistance. So its value should be the combined value of these three, R1 plus R2 plus R3. So what is the value of RP or R equivalent? We are going to calculate here with the help of Ohm's law. Okay. So as you know that what is Ohm's law? V equal to IR. Here what we are going to calculate? We are going to calculate here R for this whole circuit. So here R will be equal to V divided by I. Okay, so here one thing you should keep in mind is this voltage for all these three resistors will be same. Okay, because here we are measuring voltage between point X and point Y. So here current is different. Here I1 current is flowing, here I2, here I3, but voltage remains constant. So from here with this formula we are going to calculate it. Okay, so as we know that here I equal to I1 plus I2 plus I3. I equal to I1 plus I2 plus I3. So according to Ohm's law, what is I? I equal to V by R. According to Ohm's law, I is equal to V divided by R. So I1 will be equal to V divided by R1. So you can see here I1 is equal to V divided by R1. I2 is equal to V divided by R2. I3 will be equal to V divided by R3. This is the value of current with respect to Ohm's law. Okay, so as we know that I equal to I1 plus I2 plus R3, in place of I, it can be replaced by V by R. In place of I, we can write V divided by R. In place of I1, which is V divided by R1. In place of I2, V divided by R2. In place of I3, it will be V divided by R3. You can see it here. So V I equal to I1 plus I2 plus I3. So in place of I, it can be written as V divided by RP. In place of I1, V divided by R1, then V divided by R2, then V divided by R3. Now you can see that in all the terms, V is common in the numerator here and here. V is common. So you can cancel V out here. So here 1 by Rp, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the conclusion here. So here what is the conclusion in case of parallel connection? 1 by Rp, okay, is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. This one you should keep in mind. Okay. So in case of series connection, what happens? Resistance can be directly added. That is R equal to R1 plus R2 plus R3 like that. In case of parallel connection, 1 by R1 is equal to 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 like that is goes on. Okay. Now these are some of the examples related to parallel connection that we are going to solve here. In the circuit diagram, this is the circuit diagram which is given. So in the circuit diagram, suppose the resistor R1, R2 and R3 have the value 5 ohm, 10 ohm and 30 ohm respectively, which have been connected to a battery of 12 volt. Here this battery is 12 volt. Here the first resistor, this one is 5 ohm. Second resistor, this is 10 ohm. Third resistor, this is 30 ohm. Okay. Calculate first point the current through each resistor. Through each resistor, what is the current passing through? So, according to Ohm's law, as you know that V is equal to I R. Okay. So, what is current here? I is equal to V divided by R. So, this is our formula to find out current. Okay. Now, for the first resistor, suppose here I1 current is flowing. So, I1 will be equal to, for all the three resistor, potential difference will remain same. So what is potential difference here? 12 volt it is given. Okay. So 12 divided by R. What is R here? 5. 5. 12 by 5, 2.4 ampere. Okay. Then I2 will be equal to 12 divided by 10. What is 12 divided by 10? 1.2 ampere. Now I3 will be equal to 12 divided by 30. What is 12 divided by 30? 0.4 ampere. Okay, so this is A. Now B, the total current in the circuit. What is total current? Total current is nothing but summation of these three. That is 2.4 plus 1.2 plus 0.4. 2.4 plus 1.2 is equal to 3.6. 3.6 plus 0.4 is equal to 4 ampere. So 4 ampere is current is flowing through this circuit. Okay, that is B. Then C, the total circuit resistance. What is total circuit resistance? So equivalent resistance. So what is equivalent resistance? 1 by Rp in parallel connection is equal to 1 divided by first resistance, that is 5, plus 1 divided by second resistance, that is 10, plus 1 divided by third resistance, that is 30. Okay. Now if you will take the LCM of 5, 10 and 30, it will come 30. Now this is 6 plus 3 plus 1. 6 plus 3 is 9, 9 plus 1 is 10. So it will be equal to 10 by 30. Now here 1 by Rp is equal to 10 by 30 equal to 1 by 3. Now if you reverse this one, Rp will be equal to 3 ohm. So this is the value of equivalent resistance. So the total circuit resistance here is 3 ohm. Okay, so this is all about this question. Here we have another question, that if R1 equal to 10 ohm, R2 equal to 40, and R3, R4, these respective values are given. So these are R1, R2, R3, R4, R5. Here this is the battery connected and its value is 12 volt. Here total resistance in the circuit, the total current flow in the circuit. What is the total resistance? Now here you can see R1 and R2 are connected in parallel. Okay, so first we need to find out the total the resistance of these two, then the resistance of these three. After these two are connected in series. Now you can see that suppose here we will take these as R and this one as R dash. Now from here current will flow through R, then current will flow through emitter, then current will flow through R dash. So now this is connected in series. So first this one will find out the value of this, then the value of this, then according to series connection we will find. So here 1 by R equals to 1 by R1. What is the value of R1? 10. 1 divided by 10 plus 1 divided by R2. What is R2 here? 40. Okay. So if you solve this one, 5 divided by 40. So here R will be equal to 8 ohm. So here the resistance is 8 ohm. Now we'll find out this one. 1 by R dash equal to 1 divided by R3. What is the value of R3 here? 30 plus 1 divided by R4, that is 20, plus 1 divided by R5, 60. So it will be 62 plus 3 plus 1. So here R dash will be equal to 10 ohm. Okay, so here R dash is 10 ohm. This one is 10 ohm. So here this is 8 ohm, this one is 10 ohm. And let me write this one. This one is 8, this is 10. Now these two are connected in series, this and this entire thing. So here 8 plus 10 is 18. So the total resistance of the circuit, then first one is 18 ohm. Now B, the total current flowing through the circuit. What is the total current? So as you know that from Ohm's law, V equal to IR, that is I equal to V divided by R. So what is the value of voltage here? 12 volt. 12 divided by equivalent resistance, that is 18 ohm. So 12 divided by 18, you solve this one. What is the value of this? You calculate that much ampere. Now find out this one, what is the value of 12 by 18, and comment in the, write the answer in the comment section below. Okay. Now in the next video we'll compare parallel and series connection. Okay. Thank you and have a nice day.